Okay, guys, we're going to do one more combustion reaction, and if you can do this, you can do anything. All right, I picked a real good one. We have the combustion of yet another type of compound. If you recognize your functional groups, especially with the OH at the end, this is an alcohol, and it happens to be isopropanol, which is also known as rubbing alcohol. So what we're going to do is react it with oxygen. It's going to burn. It is a flammable substance. And again, the same two products each and every time, carbon dioxide and water. All right, so what we're going to do is tally everything up. So we have C, H, and O, C, H, and O. All right, carbon, 3. Hydrogen, be careful, 7 and 1 is 8. Oxygen, 2 and 1 is 3. Now we got carbon dioxide, carbon 1, hydrogen 2, and oxygen 3. All right, so what we have here is carbon 3, 1. We're going to make this 3 as well. So that changes the carbon to 3. And now the oxygen is 3 times 2 is 6, 1 is 7. Okay, hydrogen. We have 8 and 2. We're going to make this 8 as well. So we're going to multiply by a factor of 4. The hydrogen is now 8. And the oxygen is now 3 times 2 is 6, plus 4 is 10. All right, so we got ourselves a little bit of a problem here. How are we going to make the oxygen work? Well, from the previous example, we showed you that you cannot alter the formula of the alcohol. So there's an oxygen in it. So what we're going to do is use the number 10 as our target. That's what we'd like to have for the oxygen content, since the carbon and the hydrogen are A-OK. From it, we're going to subtract 1. And we're going to be left with a difference of 9. How are we going to get 9 from an even number of O2? Very simple. Here we're combining. When we use the 9 halves, we're going to multiply 9 by 2, which is 18, and divide it by 2, which is 9. 9 and 1 is 10. But even though this reaction is technically mathematically balanced, it's not cool to leave it like that for a chemist's point of view. So we got to have all whole numbers. So we're going to multiply the whole reaction by a factor of 2 because of the subscript. So that will make the reaction be as follows. You're going to have 2 C3 H7 OH, and you're going to have 9O2. And then you're going to have 6 CO2 and 8 H2O. And again, you got to check your work to make sure that the reaction is, of course, indeed correct. All right, carbon, 2 times 3 is 6. 6, checks. Hydrogen, be careful. You have 7 plus 1 is 8. 8 times 2 is 16. Once again, 7 and 1 is 8. 8 times 2 is 16. 8 times 2 is 16. That works out. And now the oxygen, we have 9 times 2 is 18, plus 2. It's like writing the formula twice. 2 oxygens and 18 oxygen is 20. And now the other side, 6 times 2 is 12, plus 8 is 20. The reaction is balanced. We're done balancing reactions for now. The next equations that we'll be balancing will be redox, but that won't happen probably until next week. Okay, now you're done.